Good afternoon, everyone. I'd like to thank you all for joining us today in our continuing education series. Today, our featured topic is estimating fiber projects. My name is Jessica Petrovoy, and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about estimating fiber projects is Christopher LaBonge. Chris is the president of the Adtell group and fiberoptic.com. When Chris is finished, we'll take questions from the GoToWebinar question box located at the bottom of your screen. We'll have a question and answer session. Thank you again for joining us today, and at this time I turn the presentation over to Chris.
Thank you very much, and good afternoon to everybody. I appreciate your time this afternoon and your willingness to join us on a topic. So as Jess had mentioned, the topic is going to be estimating fiber projects. And one of the things I'd like to kind of kick off saying kind of from the very outset here is upon building the presentation, I actually got some interesting feedback from a couple of the participants who were helping me kind of outline what we would put in today's topics. And I guess the idea of how broad potentially this topic could be, arose. So one of the things that I'm going to say is we're probably going to take this from a 30,000-foot view of estimating projects. Some of the questions kind of pointed to the direction of what type of project are we looking at estimating. And is this from a contractor's point of view, or is it from a bid proposal point of view? Or is it from a point of view where someone may be wanting to build out their own individual fiber network, i.e. a university or municipality, and they were looking to get some information on what it might take to estimate the scale and scope of the project that they were about to undertake. So those three different areas actually have probably very differing I guess, angles that I would want to take and discuss with you. So we're going to kind of take this one at a high level, talk a little bit about each of the three potential areas, and then maybe in the future, as we maybe cycle through some of the content and when we revisit this in the future, I can take some of your feedback towards the end of the presentation and find out from our audience, what type of participants did we have? Did we have contractors that were looking for, how best to bid, or whether it was network providers or operators who wanted to get a little bit better idea of how to estimate kind of growth and things of that nature. So we'll just go ahead and start at the high level here then. So estimating fiber projects, obviously, if we're going to take on any kind of project, whether we're looking at it from a bid perspective or we're looking at it from a ownership perspective, obviously there's a few things that are going to be similar. And those are common goals. So some of our common goals are going to be, regardless of whether we're building or planning a network, we're going to want to make sure that we're going to get good quality workmanship. We're going to want to make sure that the individuals who are working on our project are properly trained and certified. We're going to want to make sure that the materials that are being used are appropriate for the environment, the conditions, the potential speed or bandwidth that we're trying to achieve over the fiber. We're also going to try to make sure that the work can be completed in an appropriate amount of time. So, we don't want a contractor to come in and rush through a job, or we don't want to take on a job that, if we're a university, perhaps we don't want to take on a job if we've got a summer expansion while students are out of school. And we need to get it done within a given window, that we don't take on a job that may exceed the time limitations that we have to conduct such a project. So, managing, and those are kind of the variables there. So managing the quality of work with the level of craftsmanship, the materials, and then the timeline. Some of the other things that we want to make sure that we take into consideration is what is a fair and appropriate price. Are we as a contractor, are we putting too much overhead, or are we not counting for as much overhead? We're trying to be competitive to win that project, We're really not taking into consideration some of the overhead, the back office support, things of that nature that typically go into a project. But when you feel like you're in a very competitive bid situation, you sometimes kind of try to focus on just the labor hours and the man hours that are potentially in the field and ignore some of that back end or overhead that really needs to be considered. And then what is, obviously from the contractor standpoint here, what is a fair, profit margin that we could expect to receive? Being in the world that we're in, where we actually support at fiberoptic.com many contractors, many municipalities, many do-it-yourselfers, we kind of see the full gamut of what people are looking to try to receive as compensation for the projects that they have underway. And obviously, it depends on supply and demand. What are the conditions? Is it hurricane relief work? Is it something where there's not such a stringent time? Obviously, fiber demand out there right now. There's a lot of Google Fiber projects that are going on, and so the number of individuals out there with this type of skill is probably much less than the demand would be at the particular moment. So therefore, you're seeing some sort of fluctuations in price. And then, in some scenarios, like with Google Fiber, they actually have you work to a certain number that they feel gives you a 20 to 30% margin of profitability, so that you can be relatively healthy, but they also don't want to make sure that they're being gouged. So making sure you fall within that fair profit kind of margin. What is the scale of the project is something else that needs to be considered. As we talked about before, the larger the project, potentially the more overhead that you're going to have, the more back office support you're going to need. You're going to need logistical support. You're going to need project managers. You're going to need accounting people. You're going to need foremen potentially to manage your field resources. And then also the financial considerations that go along with larger scale projects. Many bids that are out there for the municipalities require bid bonds, or they're going to hold a certain percentage of the bid to the end of the project, and even quite a bit after the end of the project for warranty purposes and things of that nature. So, are you as a contractor prepared and capable to manage the larger projects? Everybody wants that that huge opportunity, that one that's going to put them over kind of over on the profitability scale and kind of make them as a company. But most companies actually wind up failing just because they've got too much work and they just can't manage the amount of work and the margins. They underbid it. They have a ton of work, but unfortunately the margins aren't there, so they just kind of find themselves as that hamster on the wheel, where they're constantly busy, but they're not necessarily profitable as an organization. So you got to make sure that you're taking all those elements into consideration. So when we talk about the quality of work in the previous slide, along with that quality, as with you would assume, is some sort of trained individual. To get somebody of high quality, they either have to have a ton of experience, or they've had to go through and learn from other individuals who have had that experience. And in the fiber world, what we've seen over time is the certification is becoming much more prevalent. Used to be that you would find pretty much anybody with an electrical background, electrician, who had experience pulling cable, would be the individuals that would get called up to provide this type of service. Hey, if you pull cable, I need this fiber pulled. To the layperson, fiber or cable, there's no difference. So they would bring an electrical contractor, have them pull it, perform the services, and then go along their way. But over time, what you'll find is that we've seen a lot of jobs that have just been incorrectly managed from a perspective of professional fiber optic installation, The electrical background individuals are fantastic, people to start with the project. They understand pulling cable, they understand the fire code and things of that nature, but there's a lot that goes into it from a splicing and testing standpoint that is quite a bit different from copper. And so therefore, the certifications show and prove that the individuals who are doing this type of work have a background, have actually done fusion splicing, have done OTDR testing to ensure that the work that is being completed is sufficient to a caliber that you would want as a customer. To talk about some of that, as you'll see in the market nowadays, there's many different types of levels of training. I use as an example the fiber schools levels, which we have an installer, a technician, a master's, and a professional level training. And that's kind of the track that you can follow to become proficient at any particular skill. In the industry, I think you would also find FOA and ETA have similar. I think installer and technician levels are very common within those organizations, as well. So there's also levels: level 1, level 2, level 3, level 4 technicians that you'll see within the industry. So as long as you have somebody, depending on what you're wanting to do, as long as you have somebody that has a background and has a certification, I think that's a great starting point. One of the things that I would kind of stress to you is if you're going to be looking for an individual, or you are an individual, you should be trying to achieve the highest level of certification you can to kind of differentiate yourself from those other individuals out there. For those of you who are looking for professionals, some of these basic classes that are out there are 2-3 day classes, and when you're trying to have a contractor who's going to come in and potentially do $20,000, $30,000, $40,000, $50,000 worth of work, you typically want to make sure that they're not somebody who's been through a class in 2 days, maybe got a little bit of theory, but really is limited in the amount of hands-on experience that they have. And so I would look for those upper-level certifications as to reinsure that you're getting quality work. Some of the other areas that you can look at is also ourselves, and again the ETA and FOA offer disciplines. So if you have a major project that is fusion splicing, we do have master's level classes and technician level classes around fusion splicing. Perhaps if you're looking for a long haul network that you're building, you want to get somebody who's extremely experienced in testing. We have masters in testing, or we have fiber characterization type disciplines that could also be taught. Another discipline is air-blown fiber installation. So this is a installation process which is a little bit non-traditional, where the kind of the outside conduit or jackets that you would typically see are put into a building or a structure, way in advance of the fiber, and then actually the fiber, the actual bare fiber, comes back in and is actually blown in after the fact. So it requires some special machinery to make sure that you're not damaging the fiber. So both ourselves and actually the manufacturers of the equipment, Sumitomo being one, actually require certification for those individuals who want to be installing Sumitomo air-blown fiber. And then the ultimate culmination is kind of the combination of both, which is the professional tracks that is outside plant, splicer. So we have a professional track with outside plant testing as well. So if you're going to be doing outside plant testing, long haul, fiber characterization, things of that nature, look for those disciplines. Ask about their experience, and if you're looking for continuing your education, look to that discipline that you think makes the most sense, and try to differentiate yourself from some of the other people that are out there. Because one, you are going to pay, and how this comes into the estimating is, one, you are going to pay a little bit more for these types of individuals, that have the skill set. But I promise you're much more likely to have a very good experience. And and on the opposite side, if you are an individual, you can command a higher dollar amount for this type of work. You have to sell your certification You have to promote the fact that you have this level of certification. You have to explain why it differentiates you from others in the industry who, again, through FOA, who can take it at any, community college around the country that doesn't even require them to do fusion splicing. There's not all certifications are created equal, and that's something that you need to take into consideration when you're looking at how somebody might be bidding to you or what you might be bidding to someone else. The other obvious thing that comes into mind is the quality of work is what materials are being used and what tools are being used. So I could very easily come to quote a job and buy my materials directly off eBay, probably directly off the boat from China, and what I would call these is probably contractor grade products, which is something where the contractors are looking to win bids. It makes sense. They have to have low cost in a lot of situations. But be careful if the pricing is too low. We've worked with a local municipality, here in Pennsylvania called Lansdale Borough, and there was a bid that came out, and the contractor who won the bid was actually out of Canada, but was buying Chinese fiber directly from China and dropping it into the states here at a much much lower price than anybody else could afford to do, and it was a match spec type of bid, and it did win that opportunity, but it also proved that when the customer received that material, the color codes didn't necessarily match up correctly. The fiber works and performs probably as you would expect it to, but it was all gel-filled cable, which took longer to install. So there's a lot of things that kind of go into it. I would recommend you talk to someone at fiberoptic.com or one of our instructors or even the contractors that you're dealing with themselves and ask the types of questions. What type of materials are being used? What is the benefit of these materials? What is the drawback? And ask them and make sure that they're able to answer those appropriately. Because in many situations, I could tell you that the Corning enclosure, even though it is twice as expensive, can be just as cost effective in an overall project as something that's coming over from overseas, because the amount of workmanship or craftsmanship that has to go into that in the field is greatly diminished because it has a quicker termination time, quicker prep time, things of that nature. So don't be completely fooled by that, and ask some of those questions. Make sure you have the right tool for the job. Mechanical splices are typically used for what is called a temporary repair. So if someone's going to come in and they're going to provide you a quote for splicing or setting up a network and they want to put in mechanical splices, I would kind of question that. It's probably for contractors who don't have fusion splicers. A fusion splicer may cost between $4,000 to $12,000, and maybe just isn't in the budget for a contractor who's just getting in the business, and they decide to go with a mechanical splice, which might be $12 a piece. It'll do the job, and get a network up. But typically, like I said, when we train, we talk about them being temporary repairs, just until you can get a fusion splice in there. So know the materials. Make sure that you're asking for the right products. There's a whole bunch of higher level theory that we can talk about with why you would want a fusion splice over a mechanical splice for loss and reflectance and durability and things of that nature. But we're not going to get into that in this presentation. But you need to understand that those types of things are sometimes corners cut as ways to kind of drop the price and be more affordable. But understand what comes along with that. Also, talk to the customer or the contractor and talk about expansion. I'd be leery of a contractor who was saying, you know what, here's you want 12 fibers, here's 12 fibers. We always talk about expansion, and we really recommend that people buy 2 to 3 times the amount of fiber that they typically think they need today. It's not long before you wind up using the fiber. So, as a rule, always overbuild. It's so much less expensive to have it pulled in. The labor cost is really going to be a huge driver in any project. So the extra 12 fibers, or 24 fibers that you may get if you were really only needing 12 now, is really pennies on the dollar compared to the labor rate it's going to cost for someone to come back in 12 months or 18 months to reinstall that. Never mind the fact that you might have filled up some conduit paths and started to create a scenario where there's just not enough availability of conduit. So always take the time, put in more than you need, think forward, ask your contractors to make sure they're thinking forward for you, and that they're considering taking your best interest into consideration, because that's really what's going to, to me, be a definition of a good working partnership with anybody that you may have helping you out in your projects. Now this kind of starts to bleed a little bit more into the design side, but I think it's one of the things that may be broken out later in other areas. But for now, I think it's worth discussing at this in this presentation, which is when I'm estimating a project, what type of network do I want to build? Do I want to build a single mode network? Do I want to build a multi-mode network? Do I understand what single mode and multi-mode even are? So these are some considerations that you really need to take into place. They really relate to what is the maximum amount of bandwidth that I want to achieve over a given distance. Okay, so that's why we have this point up here called distance, because we're saying the distance and bandwidth are really interrelated. And most people don't understand that. Most people think that, oh, if I'm going to put fiber in, this is going to be good for 100 years and I have unlimited bandwidth. And that's not the case. Again, another instance where we helped a customer here locally was he had some copper that he was trying to do 100 megs on over, I forget what the distance was, but it wound up being over 300 meters of total distance once we pulled in the fiber. So we pulled in fiber. He was very adamant that he wanted to stay at the lowest cost possible. So we actually gave him some 62.5 micron fiber, 300 meters, and he was fine, kind of jumping up into that range, and was comfortable with that. But then a couple of years later, he wanted to turn that fiber into 1 gigabit. And so he just changed out the optics on the transmitter and the receive side and flipped it out to 1 gig, and all of a sudden his link went down. So what I'm trying to illustrate here is you need to understand what is the distance. The distance was okay at 100 meg, but when you wanted to go to 1 gig, the same fiber wouldn't carry that same signal. It's a phenomenon actually called as modal dispersion, with multi-mode fiber, where the core is very large, and so therefore as you send signal down that multi-mode fiber, the different pulses of light sometimes travel and bounce off of the outside core at different angles, and you get what's called pulse spreading and interference. So the signal as it propagates down the complete fiber length at the other end is just receiving constant light on. It doesn't see the Morse code that is typically what makes up a fiber optic signal, on, off, on, off. It's not seeing the flashing. It's literally just seeing a dim, steady light, and therefore it doesn't know how to interpret that. So those are some considerations that you need to take into, or some two variables you need to take into consideration. The other thing is, what is your existing infrastructure? Obviously, if your existing infrastructure is 62.5 micron multimode, you're not going to be able to mate a 50 micron OM3 up to that fiber. So you may have to look at either pulling that out, pulling the whole length back in at 50 microns, maybe swapping over to single mode completely, so that you really have a much longer ramp up for running into any kind of modal dispersion or speed issue. So we really always recommend, if you can, go with single mode. I really don't understand the value of multi-mode in any applications, any longer. For a long time, it made some sense because the cost of the transmitters and receivers were much higher for single mode fiber, so they were more costly. It has to do with the way that the actual lasers are manufactured for single mode versus the LEDs that are manufactured for multi-mode. So, but China and other areas of the world have really only been installing single mode fiber. So the cost of the single mode electronics has come down, and it's really pretty much on par, or becoming closer to on par than it was in years past. But the interesting phenomenon here is actually that for a long time, multi-mode fiber was actually more expensive to manufacture than single mode. So there was this kind of relationship where, depending on your length and the number of transmitters and receivers you needed, it actually made more sense to go with single mode over multi-mode, even though most people always believed that multi-mode was just cheaper, and more affordable. As an example, let's say we had a 2-kilometer fiber that we were running out to a security camera at the end of a mine, a coal mine entrance or something along those lines. If we only have a send and receive, which is 2 transmitters and a transmitter and receiver, and then we had 2 kilometers of fiber, the extra cost of the multi-mode fiber at that length actually outpriced the benefit of the electronics. So it actually made sense when we would design it for people, and we were estimating the project, we actually flipped it over to be single mode. One, because it gave them much longer, like I said, a lifespan on that fiber, because you're not going to go backwards from single mode. But it was more cost effective to use single mode, and most people just wouldn't consider that to be the case. So here's some examples of what we're talking about when we look at some distances, and I have 2 slides that are very similar. I kind of grabbed them from 2 different presentations that we had, and the numbers are slightly off. One's more rounded in general terms, and the other's a little bit more detailed, but I'll show them both. But here's an example of kind of what we're talking about here. So OM1, which was the 62.5 multi-mode, and gigabit Ethernet speeds, you really can only get 300 meters of effective distance at the 850 nanometer wavelength. And really what I want to illustrate to you here is look at the jump that happens when we go to 10 gig, the distance that we get at 10 gig. So if we have a 62.5 today, and we're operating at, let's just say 250 meters within the spec or the threshold, we're fine. And just like we had the customer who did, we pulled those optics out and we throw 10 gig optics in there. Immediately, the effective range of that optical transceiver is 33 meters at 850 nanometers. So a huge drop-off, almost 10% of the effective range that it was at 1 gig. So you need to make sure, as I talked about earlier, you need to make sure you really understand if I get a contractor or I'm estimating a project, yes, the 62.5 micron fiber might be the lowest cost fiber available to me today, but is it really going to service me into the future? If I'm doing 1 gig today, I promise you it's probably not 3 years, 5 years max before you have to go to 10 gig. And then you're going to basically have to pull that fiber all over again. So if you're talking to your contractors or you're designing your own network, you might want to look at the OM3 and the OM4 fibers. Yeah, the OM2 is basically the 50 micron multimode, which had some benefits slightly over the 62.5, but really not nearly as much as we get when we get into the OM3, which is what we call laser optimized fiber. So laser optimized fiber is essentially fiber that has been optimized for what is called a VCSEL laser, vertical cavity surface emitting laser. I believe it stands for, versus the LED. So what we're able to do with the VCSEL is, with the 50 micron core, it's a very small core compared to the 62.5, so we needed a more narrow spectral width to launch 100% of that energy or power or light into the fiber optic core. The reason that we as a nation had the 62.5 micron core years ago was actually because in the LEDs, the spectral width it was very wide. So I kind of liken it to a flashlight that you can kind of turn the head of the flashlight and make the beam more narrow or more focused. So the 62.5 was opened up and it was created a wider core because the spectral width was almost like the flashlight that has the widest angles associated with it. And therefore, when we launched at the core, we were really only getting, let's say, effectively 50% of the power of the actual of the LED into that core. So we opened it up to try to get that 50% versus the 50 micron, which would even give us less. So it was kind of a trade-off. We got more power in there, but we created this inverse, problem, which was called modal dispersion. So that's just a little background on that. But the 50 micron, core, OM3, as you can see, we're starting to be able to get into the 10 gig, for 10 gig, we're still able to get into that 300 meter range, and then the OM4 is around 550 meters for that. I think I actually have a mistype on that on the 1310s on those. I gotta just double check those, but that's kind of the idea. I really recommend, if you're going to put multimode in anytime soon, you really have to look at OM3, OM4. These are not going to be your traditional orange jumpers or cable. You're typically going to see this as an aqua fiber optic jumper or fiber optic patch cable, so you can easily identify that this is OM3 or OM4 fiber. So make sure you take a look at that. If you're talking to people or getting quotes on that, make sure that you understand that series of fiber, that laser optimized fiber, is going to have a certain type of appearance that you want to make sure you understand. And then look at where we get with the 9 micron core on a single mode fiber. Gigabit Ethernet, anywhere ranging from, there's a couple of standards that I'll talk in the other slide about, but anywhere from 5 kilometers to 70 kilometers in distance is what we can get on a single mode fiber. So just completely blows away the multi-mode fiber, in the capabilities for what it can deliver in distance at any of these ranges. And then I think once we even get into some of the higher level ranges, let's say 40 gig, 100 gig, what do you think is going to happen to those distances on multi-mode? They're just going to continue to erode, where single mode will be able to hold on to those distances for a much longer duration. So this is that chart, very similar to the previous one, but we're seeing again our OM1, OM2, OM3, OM4 on the side. But really, what I wanted to show you with this chart, even though a lot of these numbers are kind of similar, is we don't even claim that the OM1, OM2 can support 40 gig. Okay, so if you're a university, you're a hospital, you're anybody who is probably pushing any significant bandwidth over your network, and you have OM1 or OM2 fiber, you probably need to start to look to pull that out and get that replaced. And this one specifically here is not going to show us the single mode because this is just a chart on the wavelengths for multi-mode 850 and 1300. But you need to look hard at the budget and say, okay, we're going to need to start to move up and have some OM3 or OM4 installed, or we're going to have to go single mode. Universities, obviously you have students. Hospitals, it's the X-ray and MRIs and all the other stuff that's kind of going over the networks that are really causing tremendous amount of bandwidth limitations, and therefore they need to up those. And 100 gig is something that we're seeing pop up quite frequently nowadays. And again, look at our distances. We're really only looking at about 150 meters at a best case scenario for 100 gig. So, so again, that I would recommend you talk to a design professional. Contractors are great. Contractors are installers. What I really would recommend is you talk to someone who can discuss with you and help you design it. I mean, we do have design services. We can help assist individuals on a consultation basis and help them design the network. But make sure you understand what you're trying to do, and then get the right design so that you're not rebuilding immediately following the deployment of a project. So this is a slide that makes up for the lack of the single mode on the previous screen. This is some standards for IEEE 802.3, which has 1000 base LX fiber, 1000 base LX10, EX, and ZX. If you guys are buying transceivers, these suffixes are things you're probably relatively familiar with. But again, it talks about what you're getting with the ZX at the 1550 nanometer wavelength. You're going to be able to get up to 70 kilometers. At the BX10, really this is very similar to the fiber to the home type of deployments, where you have maybe a 1550 going back, or I'm sorry, using 1550 for the RF signal down, but then you would have the 1490 and 1310 for your Ethernet and internet connections. So that is typically spec'd out at about 10 kilometers. Fiber to the home networks are typically all running at about the 9 to 10 kilometer distance. So that was kind of specifically built for that. I'm not sure that anybody on this webinar today is probably looking at a network that's going to be to that extent, but also just kind of goes along with, like I said, you really aren't going to be hurt or inhibited by putting a single mode network in your current infrastructure. Like I said, universities that have multi-mode, I know most of them are actually flipping that over to fire suppression systems and alarm systems that have very, very low data rates, just because they really have no use for them on the networking side any longer. So when you look at selecting, some materials that you would want to use for your project, we kind of look at that. What is the Corning grade versus what is the contractor grade product? So I just tried to show a few examples, here. On the wall mount enclosure side, what you'll see is that aqua fiber, right there on the corner. So the Corning, products are on the left, and I'd say the contractor grade, products, which are also acceptable, are on the right-hand side. So as an example here, on the wall mount that we have on our left-hand side there is pretty good cable management inside that. I can buy this from Corning pre-terminated. Actually, you can buy this from fiberoptic.com, pre-terminated. We call it a loaded box. So what we'll do is we'll take the box, we'll dress all the pigtails or the leads into that, so the box is very clean, and cable management is done very professionally. And then when you get out in the field, all you have to do is pull that cable stuff into another splice location or a splice box and splice that in, and you've got a very clean, professional installation. Also, Corning units, very soft edges or rounded edges, not soft, it's metal, but more rounded edges. They kind of take some of the burrs and sharp corners out of the equation. When you're dealing with fiber, a lot of times when we deal with people who have something go down and we deal with emergency restoration, somebody just closed the door on a fiber jumper and snapped the pigtail or the cable that was coming in it, because it didn't have enough protection. It wasn't built, and designed right. You see that Corning one at the top. All that light colored or multiple colors are wrapped up in that circle there. You really want, what that is that's 900 micron fiber. You really want all that 900 micron fiber to be contained within a splice tray or a cassette, which it is there, and never have that exposed in any way to a zip cord or a zip tie, or allow that to be touched by a door or swinging object. That outside jacket actually has Kevlar underneath it to protect it from those types of kind of penetrations. And but the average contractor potentially who may go out and do an installation and use the box on the right, which is really just a box, and he can kind of manipulate it however he wants. It's not loaded. He may buy all the pieces and parts separately. Now, if he doesn't dress it out right, or just puts 900 micron fiber in there and extends it out, or kinks it, or the door can hit that, you get yourself into some trouble there. So. And then one of the final points is, the time it may take to load and mount that box on the right, and then bring the pigtails in, splice them, manage them, arrange them, versus buying a loaded box and then having the contractor just go and splice that at a separate point. A lot of times, like I said, you're going to pay extra for that Corning or that fiberoptic.com preloaded termination box. But you're going to get the performance, when it comes to speed in the field. These boxes may be a couple $100, but if you have a crew out there, a 2 or 3 man crew who's doing installation, and your labor rate is significant enough, that labor rate and the extra time it's going to take is easily going to outweigh the cost of the material. So, be efficient, be effective. Don't undercut the end user by buying, inferior materials just to kind of save some cost. Try to go in there for the materials that you feel like your team is most efficient at using, so that you get some sort of efficiencies and leverage the efficiencies rather than just the cost of a product. Rack mount, there's an example of a rack mount unit. You can see how again, it's nicely organized. Cable entry comes in from the side of the racks. They look very professional. You can see through clearly. The components are typically going to be metal versus plastic. A lot of the locking mechanisms on some of the inferior products will snap off, break. What that's going to do is the doors are going to swing open, fall on the ground. Dust is going to get in there, and it's going to cause you a mess. So again, your fiber network is a costly investment for anybody. We really recommend that you take some precautions to keep it operating efficiently and effectively. At the bottom there, again, another good example of a Corning enclosure versus some sort of other enclosures. This enclosure at the bottom is actually what's called a OptiTap enclosure, where in this other enclosure on the right, potentially you can go in there, you can put connectors inside that sealed enclosure, and then run like tight buffer, cable, a 3mm tight buffer cable out of the one of the grommet holes, there. This Corning device has a special connector. It's actually an SC-styled connector inside of what looks like a military or hardened outside kind of waterproof connection point. And you basically would go and you'd screw on to that enclosure at that point. Very, very common in fiber to the home applications, where again, what the telcos were able to identify was if they gave the teams cables of predetermined length, of high quality predetermined length, they can hide the slack or manage the slack better than trying to pull it off a spool, terminate it, splice it, polish it, whatever they had to do in the field, versus hanging a bunch of these and then later have the guys, instead of having to go in and open up this enclosure that you have there on the right, every time that they have to go in and add a customer, they can basically just go take a, let's say a 100-meter drop cable, screw it into one of those ports, run it over to the side of the house, screw it into the nid on the side of the house, and be done. And the labor rate there, yes, the connector costs more, but the labor rate was 1/3 to 1/4, so it just made more sense for them to kind of proceed in that fashion. So some of the things to kind of consider for that. Then when we look at SFP, so we looked at first our fiber, then our enclosure. What we need to actually send signal over, the fiber is an SFP or a small form factor pluggable, and really, again, we're looking back here at what is the value of single mode versus multi-mode. I've kind of used this example a little bit already, where we talk about the modal dispersion issues. Well, that's the fiber, but you need to match your fiber up with the appropriate transceivers as well. So the 850 and 1300 distance, again, is a determining factor. The 850 and 1300 multi-modes are going to be less expensive than the 1310 and 1550. They're going to come at a little bit higher cost. But again, when you look back at those distance charts that we showed you earlier, you're going to get substantial performance advantages, over the multi-mode fiber. So, make sure that, one, you look at, I'm going to try to do a 50 micron OM3. Well, you need to make sure that you get the appropriate SFPs that are going to be a multi-mode OM3, 10 gig or whatever it is, type of transceiver, to go along with your fiber. One of the other things that come into play with the SFPs is the power. What is the output power of that small form factor pluggable? And for some of the single mode distances, for single mode fiber, Corning SMF28, for example, which is probably the most widely distributed or used outside plant fiber optic cable, our losses per kilometer are about 0.35 dB per kilometer. So what you need to do is you need to say, okay, I've got a 5 dBm transceiver. How far can I go? Well, you've got to look at your splice locations. You've got to look at the number of connectors that you have. Let's assume a splice is a 0.1 dB loss per splice. Let's assume our connectors are probably about a 0.5 to 0.75, depending on which standard you're going to use. So you've got to add up all of those splice points and all of those connector points. You may have, I don't know, 2-3 dB of loss, in that link, just from the connectors and the splices. So do you have enough power to then also transmit that fiber, let's say 10 kilometers? Well, 10 kilometers would be 3.5 dB at 1310. So if we only have 5 dBm of power, we've got 3 dB of loss from our connectors and splices, then we add another 3.5. We're over our loss budget for that link. So we could then look at that and say, okay, well, we've got now 10 kilometers at 2 dB per kilometer. If we use 1550, well, then we've got 2 dB and then the 3 dB, which is the 5 dB, which is, honestly, we would actually want a little bit of a cushion or allowance for some other factors to come in. Typically, we say have about a 3 dB kind of buffer at the end. But just kind of doing the math for you, showing you that the same length, the same fiber type, but different wavelengths and different power settings all go into the equation when you're kind of trying to estimate what type of pricing or what type of equipment you need in your network. So this is an example of kind of what appropriate job may look like from a quality standpoint. So we've got it on the far left here, where it was basically a bunch of Cat5 cables and some fiber cables that were terminated into an old enclosure, and then what a professionally done installation would look like. You want it to be organized. You want it to be labeled. You want the appropriate warnings on there for fiber. You want to make sure that the bend radiuses of fiber are all managed. So those are the types of things that you're going to pay for in the craftsmanship. What I like in this type of work too is craftsmanship. Does that individual take pride in the way that looks and appears? Appearance is not going to be a huge factor, for the performance. It's probably going to have some, but where appearance comes in usually is, can I understand the documentation? Is it clean enough and clear enough that if I want to look and see, all right, where does this enclosure go? What is the A point? What is the B point? I can clearly identify that from the documentation that I have. Those types of things that kind of go into it. So make sure that you know what you're going to get out of the project by considering all those factors. So one of the other things that obviously come into the quality work is the speed of completion. Are you going to do this yourself? And if you are you prepared to do it yourself? Do you have the appropriate training? One other possible scenario you may look at is to train yourself and then go ahead and take the job on yourself. Or the third is, hey, I'm really in the jam, I don't have the time, I need to bring in a contractor. Some of the benefits of a contractor is, at least Adtell integration, we offer a 2-year warranty on the craftsmanship. So if something happens, if an enclosure, gets, a fiber gets punctured because of an enclosure was mounted incorrectly or something along those lines, we'll come in, we'll take care of it and support that and get you back up with no charge. Splices break, things of that nature. So when you're estimating your project, make sure you take those things into consideration. Yes, you can save money, if you do it yourself. Yes, you can save some money if you train and then do it yourself. But fiber, to me, is very much like muscle memory. We have a lot of people who come in, through the classes and can do it. But if you don't practice the skill often, you kind of lose touch. The fibers are very, very small. People who are used to working with copper or larger diameter cables, when you have to get down to that fiber and it's really, really small and it's delicate, the dexterity of your hands, comes into play. You need to, continue with this trade regularly to stay proficient at it and stay good at it. So, just take those things into consideration. What is my project? What is the speed I needed to be completed? And then, do I have the time to make sure it's done right myself, or do I need to bring in somebody to help me get it done quicker? So some of the things that we need to talk about on pricing, is what is a fair price? How do I price? We do a lot of work that is emergency, type of work. If you want to have somebody on call, you're probably going to wind up paying for that. If you want to have somebody to come in and do it, a project and bang it out in let's say a week period, there's going to be overtime involved. And then you got to make sure that you allow your contractors to make a fair profit. And I think what I would stress to you as contractors is you have to make sure that you're building in a fair profit for yourselves. I see a lot of contractors who can't pay their bills because they just get too aggressive to try to win bad business. And I think we have some responsibility, if we're bringing people in, to pay them a fair rate so that we can get a fair level of service and to keep people in business. There's a high amount of turnover in the industry for fiber technicians and telecommunications technicians. They start with one company, those companies fail, or those individuals go on to try to start their own company and then try to undercut the previous employer, and they're just taking a lot of the cost out of it. So understanding how to price, making sure that you're getting quality service, and then making sure that individual's using is able to stay in business, I think actually are valuable considerations for anybody. Google is one of the ones that we talk about. Google sets the price and actually asks you what you want to make, and then they have a form factor that says here's the margin that will allow you to make on us, based on what you're paying your people. So it actually doesn't start with you as a company what you want to charge them. They ask, what are you paying your people? And then they add a multiplier up there for overhead, and then they allow a multiplier up there for profit, and they allow a multiplier up there for some sort of travel and other kind of back office costs. So they want to know all the way down to the bottom level, are you putting good people in the field that can stay and finish the project? So that seems to be a trend which is surprising to many companies, but is continuing. So different ways of pricing. We see it out there quite a bit. We get a lot of customers who look for fixed price. This is the price that I need a fixed all-in price. This is my top line number. And those are good, but you also need to be careful, with that, because sometimes, it works well for the customer, but they wind up getting an inferior product because somebody has a fixed cost and then they have to start cutting corners at the end, which is unfortunate. unit price. We're seeing a lot more of this, going on as well, which is saying I will pay you per splice, or I will pay you per test. And then, that's something that you need to kind of take into consideration, because you have to figure out, how do I get travel? How do I get my overhead? How do I get all those things in there? And then how do I make sure that the people who are doing this work are efficient at it, and do they have the appropriate training to be efficient at it? Because if you're not quick, and you take a little bit longer with your splicing or testing, then you're not going to make enough money at unit pricing. Hourly markups or hourly rate for technicians is obviously another one that is relatively good for I guess the contractor, who knows he's able to get a steady margin over what his costs are. But you got to be careful of that with yourself as an end customer, to make sure that you know what is the ceiling, what is the max cost that I'm going to receive on this project, to make sure that it doesn't go over your budget. Overhead time, one of the things that you need to make sure that, when you're dealing with, municipalities or government organizations, is, am I calculating enough overhead? I have overhead in time. One of the things that we run into for some contractors is they don't remember to quote prevailing wage for a government job or a college. So you may be typically paying somebody 15, 20 bucks an hour as a lower level technician, but the state's going to mandate that you prove to them that you're paying up to, this is an example, I pulled this off the internet, in Bucks County, an electrician and telecommunications installation technician in Bucks County has to make a total of $86 an hour. The $54 an hour there is their labor rate per hour, and the $35 is what they need to receive in compensation, for benefits. So you have to prove that they're getting health care and everything else, and what the hourly rates of those would be. So $86 an hour is greatly inflated over what most people are paying for their technicians to do work in the field. So know where you're doing this work. Know if it's a prevailing wage job. Know that you're going to have to document that it actually was received all the way to the end, technician, that that's what he was paid. Otherwise, you're not going to get paid for the project. Other overhead, project managers. Well worth the money, but you got to remember to calculate them into your cost. We have a lot of jobs that we go out to that somebody needs to continue to interface with the customer, and when we're working sometimes 18-hour days to get out there and install fiber quickly, and we don't always have time to communicate back, and you need to make sure that the project managers are there supporting you with tracking the hours for the technicians, tracking the supplies that are being used, other equipment that needs to be shipped up there, handling those logistics. All good things and all worth the money, but don't forget that those are costs of a job, not just the technicians in the field. Overtime. You need to make sure that you're calculating overtime. If they're working over 40 hours a week or 8 hours a day, you've got to calculate that 1.5 times regular rate into the equation. Otherwise, again, you're gonna wind up getting yourself into a jam. And if you're a customer and you're needing something quickly, it's worth it to pay the 1.5. Talk to the contractor, but pay it. Because if you go into another day, you've got those people spending the night there, you've got additional costs, you've got their 1 times rate. But if you can continue to push through and not have the overhead, spend another night there and travel and all the other things that kind of go into some sort of projects, a lot of times the 1.5 times rate is a good number to spend to get that project completed in a timely manner. Other thing is people buy equipment, fusion splicers, OTDRs. They'll calculate the cost of that equipment into the equation, and a lot of times what we find is in customers who look at a price, depending on what equipment they're using. Is it a new Fujikara 70S, or is it a 40S from 15 or from I guess 10 to 12 years ago? So look at the contractor's tools, or look at the tools that are going to be used on the project, and make sure that you're not overly critical of a contractor's price. If they're using the latest tools, they're using the latest materials, they're giving you good advice, make sure that you're compensating them fairly for those points. And then again, we talked about this previously in the other slide is, if you're going to do it yourself, or if you're going to go through training or you're going to use a professional contractor, understand the price advantages of each one of those things. A training class may cost you $1,500. You're probably not completely ready to do that job on your own as soon as you walk out of that class. So you may need another $1,500 class or more. So you're gonna build a skill set, and if you want to do that and average that into the cost of the project, that's fine. But you have to understand that comes with some additional costs as well. So understand what your overhead's going to be and who's going to be doing that job. Scale of the project, we talked about too, overhead, back office, financial considerations, and project management. So project managers, we definitely recommend probably one for every 3 to 4 projects. You don't want to send technicians into the field without understanding the logistical and accounting and management support that they need in a back office scenario. I would definitely recommend that you see value and you allow people to have project managers on the job to get it done correctly. A lot of people want to project manage the team in the field themselves. You shouldn't overpay for project management, but I really recommend you see value in that. Accounting. You basically want to make sure that you have the accounting departments, handling any hourly expenses, things of that nature that need to be documented and tracked. Logistics. That you need to make sure that you're getting the supplies there. A lot of times we do work at venues that are either musical venues or stadiums and things of that nature. And staging is a big problem. You don't always have a lot of room to stage. So you got to make sure the logistics are all coordinated very accurately. So when you have a big project, make sure that you're thinking big and you understand what additional resources are needed on some of the larger scale projects. As I talked about kind of before too, you've got the financial considerations, bid bonds, sometimes up to 10% of the project. Payments. A lot of times on these projects, we work for bigger contractors, and we're 90 plus, to 180 days out sometimes on getting paid. A lot of times they won't pay you until they've been paid, and you've got this float that you've got to be very careful of as a contractor to make sure that you're not doing sub work for somebody and then just not getting paid and not being able to support your staff while you're waiting for that money to come in. Wage rates, we talked about that too. The financial considerations, got to make sure you understand every county is going to have its own prevailing wage rate. So you need to know what that wage rate is for that county. You need to be able to look that up and make sure you're paying those individuals appropriately. If they do one job one day in one county and another job another day in another county, you have to compensate them differently. The value of that project manager. Larger projects require that strong project manager because they require daily, weekly, or even milestone-driven reports and updates. And they need to assist that management with the staff hours, looking at overhead for your both your customers and yourself. So we actually have, like I said, several project managers who are involved in each one of our projects to handle those logistics and problems that arise in the field. We get access issues. We get travel concerns, delays. A lot of our travel is by plane or long distance. We're driving 2 days to get to a project or a site. There's a lot of elements of life that can happen and get affected by by these projects. So, understanding the project and the success of the project is influencing by understanding what the deliverables of the project are. So what we're trying to start to get into here is talk about your project, scoping out your project. Did you spell out, with a statement of work or other type of document, those things that are really required by your, contractor or what you're looking to do internally? Were they outlined, defined, and are they documented? So that's a very important part of any kind of project, is that the prep time that goes into preparing for a project. And that paperwork before the project should be things as we have down here, statement of work, which requirements of the customer and the expectations of the contractor. They need to be clearly defined. You know, are you going to potentially put an RFP or RFQ together, which is a request for quote or a request for proposal? And then also, do you have a signed contract with your either your customer or your contractor with those clearly defined deliverables outlined so that there is no ambiguity? We rescue a lot of projects. The DAS or distributed antenna space right now has a lot of people entering the market, and there's a lot of projects that are being incorrectly managed and handled. We're brought in to actually fix a lot of miswork in splicing or testing that just can't meet spec. So those contractors that are out there doing this work that don't have a clearly defined scope of work are being kicked off jobs, maybe unnecessarily, or customers who are not defining what those specs are kicking contractors off jobs unnecessarily because they just really, truly didn't know what the spec was when they started that work. And they really need to be able to know that, to be clear. So when you look at your budget and you're starting to put your budget together, you need to understand what is the size and scope of the field or the project that you're trying to undertake. Are you interacting or with any existing systems? Do you have to integrate with systems like we talked about before, the single mode or multi-mode existing systems? What is the skill level of the technicians? Do you have master technicians and then maybe some lower level technicians that you are bringing out to be assistants or grips or apprentices? What are the technical specifications of the project? Like we talked about before, are you trying to do 10 gig? Are you trying to do 100 gig? Are you trying to just get this up quickly as a temporary solution? And then also, what is your schedule? Shorter the schedule, the tighter the schedule, obviously the more resources you need to throw at it, and therefore you have potentially a higher cost that will be associated with the project. So when we look at outlining, these are some of the elements of what we see in a project scope of work. You need to outline what are the objectives, right? Is it clearly identified? Give some context to the project. What is the project about? What are you trying to accomplish? What are your major goals? What are the programs you're trying to achieve, with this? Because again, if we outline those, the objective is to get fiber from one place to another. Well, if the context is, hey, we're trying to get fiber from one place to another for a 10 gig system, which is going to be transmitting video, well, then the video to me implies that maybe I need an APC connector. The 10 gig implies that I maybe need single mode or OM3 or OM4 fiber. So give some context. And then scope. Clearly describe the scope that is required by the contractor to meet the project objectives. You need to make sure that everybody is on the same page when you're deploying, because there's a lot of gray area or ways of doing things that are up for interpretation. So the more narrow you can get the scope, probably the better it is for everybody. Acceptance. What you need to make sure you outline too in your scope of work is what is acceptable. Establish the milestones or management control points that say this is acceptable, this is or this is going to be rejected. Your pass-fail thresholds. A lot of people, they don't even know. They're just asking for the trace or results of the test, but they don't know what the passing results are or what should be rejected. ORL, OTDR shots. Are you asking for the documentation? Do they have to prove to you that the installation was done correctly with an OTDR shot that meets the EIA, TIA specifications? Those are things that really everybody should be asking for. That'll prevent the contractor from kind of drifting into areas that are not really the focus of the project, and making sure that they don't cut corners or use inappropriate materials. Responsibilities. Identify all the combined participants on the project. Make sure everybody understands what their role is, who's defining the spec, who's defining the materials that are being used. Is that a decision by the contractor, or is that something that you're going to decide and purchase on your own, and then just have the contractor go and install those items on your own. I really do recommend that in a lot of scenarios. To me, the best case scenario is when we talk to a customer, we actually act as the engineers and design the project, sell the equipment, and then have the contractor go and install it. That way the customer knows what they're getting, the spec. We can build the boxes here, and then you can use local resources to install and connect all the different points within your network. But you've got some sort of control over it from a design and build standpoint. The schedule, generate a schedule for the tasks. Make sure that everybody's going to keep their responsibilities and keep that timeline. And then obviously we talked about earlier too is making sure you understand the deliverables. What is going to be included in the deliverable, and what are the quality of the deliverables that are going to be received by the end customer. Make sure that when you're doing your project, you also scope out the data and documentation requirements for the reporting. Identify what you want. Make sure the project manager understands what you want. Make sure you're getting daily updates on those projects. Make sure you're also getting a complete closeout package for your records. That's an important thing. Also, identify any kind of information requirements. What information you're going to need as a contractor to be able to do the job that was estimated by yourself or the customer. These are the things that I will need to know to be able to hit this price at this point. Because a lot of times what happens is you'll give a bid, and then you're not able to get the information you need in a timely manner, and then you're burning hours because your guys are in the field, and you're on the hook for that because you've got a fixed bid project. Time, estimate the professional hours that are going to go into it. So before we deploy, we always calculate everything in man hours. So we know how many man hours we have, and then we can figure out whether we want to go into overtime or not. But if we have a budget of the customer says, hey, we're working on a mall in Rhode Island right now, and the customer needs us in and out in a week, so we have to calculate how many man hours is it to do this project. Therefore, I can then calculate how many men I need to put on the project at any one time to back into that number and get it done in an appropriate amount of time. So understanding the personal technician's hours and how to kind of back into that. And that'll also make sure that you have the appropriate number of people on staff on site to make it a successful project. So 7 suggestions that we recommend in your statement of work are the background, as we talked about, the scope of the project, any kind of references you have to other documents, standards, records. I would like this to be, I like this to meet EIA, TIA standards. Requirements for including the schedule, making sure that you talk about the schedule when it needs to be completed. Progress and compliance requirements. Making sure that you're getting progress updates and that everybody's in compliance with the requirements of the job. Making sure that the accessibility of the individuals, the working environment, the testing, and the final documentation, you're getting access to all those things. What is your deliverable to them is really what we're saying. So making sure that you have access to all of that is in this, also outlined in the scope of work. And also any kind of notes that you can use to elaborate on any of those prior points. And then one example that we have is purchasing a document. There's kind of a URL here of a statement of work guide, which is a good guide to kind of use as if you're going to define or estimate a job to an end customer, or you're an end customer saying, hey, I need to define this so that I can get an estimate from my contractors on the job. So. Okay, that pretty much summarizes the high-level points that that we had. I wanted to review. Like I said, I think some feedback that we could use going forward is, what additional information or clarity would you like? How can we break this down into different webinars talking about how to bid on government jobs, how to bid or estimate jobs for internal use, or how to bid on jobs as a contractor for external use, tips and tricks and things of that nature. So we can kind of go ahead and kind of refine that and get a little bit more clarity for you people who enjoyed it and want a little bit more information. Again, my name is Chris LaBonge, president of fiberoptic.com and the Adtell group of companies. So I appreciate your time. Thank you for joining us, and feel free to contact us with any other questions you may have, and I hope you're enjoying the webinars.